to the first technical conference of India Energy Week. It's a privilege and honor to be here, hosting the first session on the technical conference. We are at the flagship event of energy event of India, and it is impossible not to not talk about energy transition and decarbonization. I once saw a very interesting chart about how energy is transforming for us. Typically, when you see energy charts, they will always tell you that the proportion of renewable energy keeps increasing and the traditional energy is reducing. But there's a different representation of this. If you see the actual energy that is getting consumed in the world, the reality is none of the energy sources have actually come down. It's just that the energy demand is increasing in such a fashion that while the traditional sources grow, the new sources are filling up the bucket at a much faster pace. As a race, we are consuming much more energy. And what we need to do is two things. We need to really find ways of reducing our energy usage. And not just as end consumers, which is people like you and me, but it is also about industries which significantly use energy. Efficiency is the real question here. The second thing we need to do is find ways of generating energy in a much more carbon neutral fashion. So whether it is about consuming less polluting fuels or completely generating energy from ways which do not consume or produce carbon, those are the ways one would reduce and produce energy in a much better fashion. This is what we are going to talk about today in our technical conference number 1. Our session is on energy efficiency and decarbonization. And the presenters that we have are going to talk about these two elements itself, how to bring in efficiency and how to produce energy, which is much more carbon neutral. With that background, let me introduce you to the first speaker that we have for the technical conference. Preetham Methi is a senior manager of process at BPCL. He is going to talk about energy saving post modification jobs that have been completed at CCR turnaround at BPCL Mumbai Refinery. Preetham, over to you.
Well, good afternoon to all. Myself, Preetham Maiti from BPCL Mumbai Refinery. I'll start my presentation. Well, sir has already introduced, so no need to reiterate and repeat. So when we start, we can literally say that climate action is literally the defining term of this decade. And when I say climate action, the net zero targets, the climate actions, now the usage of these terms, when it all started in the year of 1971, but it literally came to the general parlance in the year of 2015 during the very famed Paris Agreement, where climate action or the net zero emissions target were the key negotiations goal during the climate combat actions. Now BPCL Mumbai Refinery as a whole, BPCL we can say as a very much responsible corporate and social entity has already laid out stringent roadmap for the net zero emission target by 2040 in line with the Government of India target by 2070. Now, before delving into the intricate detail, I would like to take you through, in a nutshell, in a very brief manner, the brief overview of BPCL Mumbai Refinery. Now, this is how BPCL Mumbai Refinery looks about. The design crude processing capacity, the nameplate capacity is 12 mmTPA. The Nielsen complexity index is 9.84. And we are the lowest specific water and steam consumer among all oil PSUs. And of course, we are a lubes refinery. Now this how Mumbai Refinery looked in the year of 1955, and currently we are the integrated modern refinery in the year of 2025. Now this is the layout, and why I'm saying this, because it's quite interesting. This is one of the best and optimized plot plan you could have ever seen a refinery where every inch of 454 acres has been tapped upon in a quite optimized fashion and in a quite efficient fashion, receiving from south and evacuation from north. Now, in the year of 2023, one of our major units, continuous catalytic regenerator named CCR, underwent one major turnaround. Now, during the turnaround, we had done modifications in our process fire heater. Now, as we all know, for the excellent and intricate details of the weighted average inlet temperature, the steam convection coils were replaced by the process coils. Now this initiative, this particular initiative, this simple initiative helped us to achieve and save 14.2 tons per day of fuel gas savings. At the same point of time, CCR, the downstream splitter, all the earlier trays were replaced by the MVP trays, higher efficiency MVP trays. And in the top portion of the column, we had included 5 numbers of additional trays. With this, what we have achieved, this has resulted in nil flaring, what used to be earlier in the tune of 1.5 tons per day. So with this, the total fuel gas savings have been achieved to the tune of 15.5 to 16 tons per day. Now, of course, the successful peaking in the cooling water circuit was also could be achieved to the tune of 48 to 50 tons per day of steam saving. Now, these 3 major energy saving initiatives have helped in the total energy saving of 6,310 MTOE and energy intensity induction reduction of a whopping amount of 1.25. So that sums up to the monetary savings of 28.41 crores per annum. Now, not only this, Mumbai Refinery has taken significant strides towards energy consumption, towards reduction of energy savings. Energy saving initiatives. We had implemented 37 odd numbers of schemes. We'll talk it in the later part. Now, very much pleased to share that we have broken the jinx and we have been the cusp of making it to quartile 1 as far as the global benchmarking indexes are concerned. Now, this is the roadmap to EIL quartile 1. Now, conversion of steam drive turbine to motor drive for the EI reduction of 2.7, that will achieve by March 2025. Energy optimization study for EI reduction by 5. Commissioning of the Kero hydrotreater, that has already been completed for EI reduction by 0.3. CCR revamp, as I've already talked upon and already talked about, it is for the EI reduction of 1.25. Now, what is our roadmap? We have already categorized plan in place to achieve net zero emission by 2040. Now, production of green hydrogen by electrolysis to the tune of 24 tons per day. Then reduction of scope 2 emission by importing 8 megawatt import power by renewable power from our neighbor company Tata Power. Some smaller steps like replacement of LPG cylinders in canteen by RLNG. Then replacement of RLNG, replacement of fuel oil with much cleaner fuel RLNG. Then replacement of LPG cylinders. Then, of course, additional import of renewable power to the tune of 10.8 and then to the tune of 60 megawatt due to our augmented electrolyzer modifications. Now, when we talk about this, these are our CO2 emission reduction roadmap. We have categorized plan in place as well. Now, before this, I would like to tell you, though the nameplate capacity of Mumbai Refinery is 12 MMTPA, through some excellent operational performance and energy performance, in the last financial year itself, we have set an unprecedented benchmark by achieving 15 MMTPA of crude processing in the last financial year, 2023-24. And we have always been able to beat our previous figures because here the motto is very simple. Add to the customer delight, 0 incident, 0 accident, or 0 breakdown. Now, when we talk about this is in a nutshell the energy performance of Mumbai Refinery. In the last financial year itself, we had implemented 37 odd numbers of energy implemented schemes, whereas the planned EI reduction was 1.7, and we had achieved to the tune of 3.75. That had got the benefit of 109.6, a whopping amount of 109.6 crores per annum. Now, with this excellent operational performance or energy performance rather, one thing always Mumbai Refinery is famous of, that is, as far as the innovations are concerned, Mumbai Refinery is always the torchbearer. And why I am saying this? Because this sort of innovations have also helped us in reducing the energy consumption. Like light liquid paraffin oil, this is being used in hair and cosmetics industry. 100N Group 3 lube oil. Because of its excellent scroll cranking properties, it is being used in recent series cars and bikes. This high-G technology, it is being used in currently this crude distillation unit deaerator for steam savings of 80 to 90 tons per day, MP steam again. Then double divided wall column. This is the world's first dual divided wall column operating under vacuum, because earlier also we had initiated and implemented the initiative of double divided wall column, but that was operating under the positive pressure. But this is the world's first dual divided wall column operating under vacuum that has been installed in our recently commissioned unit called dearomatized solvent splitter unit, namely as DAS unit. Then for our army men, we had initiated the army grade kerosene for the very first time among all PSUs in BPCL Mumbai refinery. Then MAC drill oil, because of its excellent low aromatics and environmental friendly properties, it is being currently used as drilling fluid. And we are currently the OEM, original equipment manufacturer for ONGC. And recently, the giant Schlumberger company has also expressed their interest to purchase these for their rigs in Europe. So this is one of the paramount important things I'd like to say, that though may not be directly related to the energy consumption reduction, as we all know, during the year of 2020, when the whole world was grappling and fighting with COVID, BPCL Mumbai refinery had not confined themselves only in the refinery and petrochemical business. Mumbai refinery was extremely instrumental in supplying medical grade pure oxygen to our adjacent Vengsakar cricket ground for our, the COVID patients. So these sort of initiatives are the testimonies to the fact that Mumbai refinery as a whole, BPCL, is a very much responsible corporate and social entity. And touchwood, horses for courses, as of now, IMAR has always ticked all the boxes in CSR initiatives as well. So this is the brief scheme. Now, when you sum up, when you talk about the key points, that with all the challenges and energy reduction plans mapped, digitalization always play the key and always at the helm of sustaining the environment and helping us in reducing the energy consumption footprint. Now, BPCL Mumbai refinery has constantly and continuously demonstrated in performance as far as energy efficiency or net zero or the operational excellence is concerned. Now, all these achievements, what we have talked about, be it energy performance, be it operational performance, are extremely pivotal in achieving and transforming the Make in India initiative by Honorable Government of India, because at the end of the day, as we all know, that aligning refineries for sustainable future ultimately is a multi-dimensional and a multifaceted approach. Implementing these approaches will ultimately drive us towards a lower carbon future and more sustainable future, because ultimately it will help us to drive and combat climate change and promote sustainability. With this, thank you so much. Extremely privileged and equally humbled to have this opportunity to take you through this presentation. A big thanks to BPCL, Bharat Petroleum Corporation Limited, for the guidance and unwavering support, which was extremely pivotal and equally instrumental in this journey. A big thanks to India Energy Week team as well. With this, thank you so much. It's been a real pleasure presenting this to you. Thank you so much.
Thank you, Preetham. It was interesting to see, of course, the element of efficiency that you spoke about on the turnaround. But very good to hear the broader plans that BPCL has in terms of reaching to significant reductions by 2030 and even beyond that, 2040 net zero. These are significant plans to have, and they have all the technologies, not just the efficiency part of it, but also how do you generate in a more greener way, how do you capture carbon, use it in a better manner. All of those technologies are already included here. Lovely to hear the presentation. Thank you. Ladies and gentlemen, our next presenter is going to be Ivan. Ivan is responsible for decarbonization solutions in hard-to-abate sectors. Sectors like steel, cement, oil and gas, all of which are critical for us, but hard to abate. He's based out of Germany, and he works with companies in process industry to develop efficient solutions at a more sustainable way. His topic for today is decarbonization of heat generation in hard-to-abate industry through a novel turbocharger. Ivan, over to you.
Well, thank you very much for the introduction, and also thank you to the organization for inviting me to present this topic to decarbonize the industry. Let me go to the agenda. Basically, we would like to present, okay, what is our motivation, what technology we are developing, also some of the references we have to improve efficiency. First of all, we know the industrial sector is still today accountable for 25% of the total CO2 emissions. And this is, let me say, big issue. And leaders like Heidelberg Materials, ArcelorMittal, Shell, Total Energy, BASF, they are committed to really decarbonize their processes. And we are developing technology to support on this task. But why is steel industry still responsible for so much CO2 emissions today? Because almost 40% or more than 40% of the energy used in the industrial processes is needed to produce heat. And if we can think about chemical or petrochemical processes, they are requiring temperature level of about 1,000 degrees Celsius. Or if we see cement or steel industry, they require 1,500 degrees Celsius for the processes. And in most of the cases, they are using steel coal, natural gas, or fossil fuel as a fuel. And because of that, they are producing a lot of CO2 emissions. In general, let me say, depends on the process, but the industry has set already the decarbonization pathways. But we can talk about three of the general pathways in the industry. One of them is electrification. And since every day more and more are having green power, it is possible to decarbonize the industrial processes. Second, carbon direct avoidance. It is replacing fossil fuel by using green hydrogen or hydrogen in some of the processes. And the third one is the carbon capture application, which is still, many processes are remaining CO2 and it can be recovered by carbon capture application. So this is the basics and the background. Now I would like to talk about the technology Siemens Energy is developing to support the industry to decarbonize the processes. The first application or the first technology is to improve efficiency in the process. And this is by doing waste heat recovery. We said at the beginning, okay, we are producing a lot of heat in the process, and in most of the cases, it is still remaining waste heat. What to do with? In most of the cases, the industry is still putting additional power to cool down, to clean the gases, the exhaust gases, and then blowing them up into the atmosphere. What we are doing is recovering this heat, put it in the waste heat recovery application, and we are producing, for example, electricity, which is one of the most common applications. But we can also improve the quality of the heat, of the waste heat, and then put it back in the process. Or in some other areas, like in Europe, it is being used for district heating, which is also a way to decarbonize the heat process. So waste heat recovery is one of the technologies that we are using to decarbonize and improve the efficiency of the industrial applications. The second one, and this is the focus of this presentation, is how to produce heat for industrial processes. There is already technology available, but in most of the cases, it is more on the left side, no? For low temperature, medium size temperature, 500 degrees Celsius, resistive or inductive heaters. But we are focused on the right-hand side, above 1,000 degrees Celsius. And we are not talking about kilowatt, we are talking about megawatt range for industrial applications. We said still, cement industry, they are requiring 1,500 degrees Celsius in megawatt range. And this is exactly what we are developing by two technologies. The first one is inductive heater, which is basically producing a magnetic field, producing heat. And this system is heating different media like gas, air, steam, or liquids, and then transferring the heat to the process. The second technology is the turbo heater, which is basically a rotatory machine taking air or gas as an inlet, and then via electrical motor, we are increasing the speed, producing heat that will be transferred to the process. And this is the technology I would like to be focused on today. And this is exactly where Siemens Energy is focusing to support the energy to decarbonize the process. This is exactly the turbo heater. As you can see in the front part of the picture, this is basically like a compressor, rotatory machine, coupled to a motor. And we are producing supersonic speed, producing shock waves, and this process is producing kinetic energy. And after that, the kinetic energy is converted in thermal energy, which is after that then transferred to the processes. What is the advantage of this technology? Okay, as you can see, we are not consuming any fossil fuel. So then the heat you are producing is CO2 free. Even if you are using green power, then you are decarbonizing completely the heat produced in the process. We are not using any heat exchangers, so then you can reduce the footprint in the process and also the OPEX in the facility. It can be scalable. We are now working on a demonstration equipment for 2 megawatt, but we are designing already for 5 and 10 megawatt range of this technology. And also the system demonstration, we have achieved today 700 degrees Celsius in a demonstration phase. And we are developing this technology to achieve already 1,000 degrees Celsius and expecting to be finished by the next year. So this is a way how we can produce high temperature level by using green power. This is just an example of the demonstration phase. The prototype unit is 1.6 megawatt heat thermal, and we achieve already 700 degrees Celsius by using a flow of 2.2 kilograms per second. Okay, we can control here the speed, the temperature, the flow, and in this way we can also produce the heat needed for the process above 1,000 degrees Celsius. The curve is just showing the line was the calculation or our expectations, how the machine should perform, and you can see the small dots, they were the different tests we were doing. So we can say it is a very stable performance. We can ensure that we can achieve our targets without any problem. And also, because Siemens Energy is developing machinery equipment, turbines, gas turbines or compressors, so then we have the tools and all the know-how in-house. Where we are today regarding the roadmap, with the demo application, we have achieved the readiness level number 6, and we are discussing with some partners, especially from steel or cement application, ArcelorMittal, Heidelberg Cement, to implement this application in the field. After this test or this application, then we can go to the commercial operation. Today, we are still testing the demo unit, but as I said before, we are already working in the 5 megawatt and 10 megawatt design. Okay. On the bottom side, you can see also another development, especially for the petrochemical applications, which is the rotating olefin cracker. And we are cracking olefin to produce plastic or ethylene with the solution. And this is a development in conjunction with Technip Energies. Well, I mentioned already the temperature level for the different industries, iron, cement, petrochemical applications. We are now on the 700 degrees Celsius development, but our target is to achieve by 2026, 1,000 degrees Celsius. And the third technology is everything to do with electrical equipment. We said one of the pathways of the industry is electrification. And in most of the cases, the industry has to modify the electrical infrastructure. That's why we are providing solutions with substations, transformers, STATCOM applications, condensers, everything that has to do with compensation of the power generation and the power demand. So then those are the three technologies we are doing or we are implementing in the industry to provide decarbonization application. Waste heat recovery, electrification of heat, and all the electrical applications. What about the applications? Well, this is just a couple of references we have implemented already in the cement industry, for example. The circles are showing you where are the waste heat sources, the preheating tower or the clinker cooler, where we are recovering heat in temperature level of 400, 600 degrees Celsius. We are recovering this heat and producing electricity. We can recover up to 30% of the power needed in the process, which is helping the industry to reduce the cost energy, for example. This energy is without any CO2, and the impact is going into the scope 2 emissions. And at the same time, we are now discussing, as I said before, with Heidelberg Cement to implement turbo heater to produce heat also for the kiln in this process. Here we have some references, not only in Europe, but also some applications that we have implemented in India. And you can see one of the biggest one is in Bari, up to 24 megawatt electric produced out of the waste heat. But the range, the standard range average is between 10 and 15 megawatt electric. So this is a big power generation out of the waste heat, and this is how we are increasing efficiency in the process. The other sector where we are working on is steel, and you can see all the bubbles. They are also heat sources that we can recover and produce power. But at the same time, for example, for the blast furnace, the turbo heater is feeding heat air, which is needed for the process. And also we are planning to implement it also for the direct reduced iron process. In another discussion, we are having also the application turbo heater in the reheating furnaces for treatment steel, which is also another application in this case for the turbo heater. So it brings me to the last slide. We were talking today about electrification of heat, and you can see the different industrial sectors where it can be implemented, but Siemens Energy is providing additional technology like waste heat recovery. We are producing also green hydrogen. We have our electrolyzer. We invite you to visit our stand in the whole one. You can see the electrolyzer, here, electrification of heat, and also, as I said before, one of the main topics, since everybody is talking about electrification, it is a very important grid stability technology. And with this, I would say thank you very much for your attention. If you have any question, we can talk later on this. Thank you very much.
Thank you, Ivan. You would remember I started my conversation by saying we need to find ways of reducing energy usage and we need to find ways of producing energy more sustainably. Now, the general trend is the moment you say sustainable energy, you think of renewables. But the point is, if you're able to move to cleaner fuels, even that is a significant shift. Our next presenter, Megha. Megha is a senior manager of process at EIL and brings over a decade and a half of experience in ONG. Decarbonization is a topic she's passionate about. And she's going to talk about how do you reduce carbon emissions, the impact of replacing liquid fuels with natural gas in refineries. How does it lead to reducing the carbon usage while not going completely green, but still reducing the level of emissions we have? Megha, over to you.
Good afternoon, everyone. When they say that how to predict the future, I always say that we can predict the future by stabilizing with the energy sustainability and reliability. So when we talk about decarbonization, the first thing that comes to our mind, let's go green. Maybe let green hydrogen, green ammonia, solar energy, wind energy, or maybe yeah, sustainable energy sources, CBGs, etc. While these energy technologies and innovations are crucial for our future, but alongside this push for innovation, there is another side of puzzle, that is to make our existing system more reliable and sustainable. Let's talk about India's refining sector first. That India's refining sector contributes about 44 to 5% of the country's total carbon emission. India total as of April 2024, India has a total refining capacity of 258.4, 254.8 actually mmtpa, and it is projected to increase to around 295 by 2230. So, with the increase in refining capacity, carbon emission is also projected to increase. But parallelly, we have an objective to decrease the carbon dioxide emission. So this comes to this takes to our today's topic, that is optimizing existing fuel system using natural gas. So why natural gas? Why there is so much talk about natural gas? Let's break it down. In today's world, as expert says it, it's a bridge fuel or transition fuel, or it is also named as, in one of the stall I saw that it's a thin gas. Okay, uh, why? Because while we are transitioning from high carbon content energy fuels to fossil fuels to renewable cleaner sources, this is where natural gas come in. Why? Because it has got high energy density. When we compared it with the fuels of liquid fuels like LCO or maybe naphtha, comparatively it releases more amount of energy with the same amount. And we'll dive deeper into this conversation in the upcoming slides as well. And then third, it has got reduced carbon emission. That is, when we burn natural gas, we there is relatively less amount of carbon dioxide produced as compared to liquid fuels like LCO or naphtha. Once again, it also aligns with the Government of India vision, as Prime Minister in the morning also indicated that uh, that the net energy mix, the natural gas contribution to net energy mix of India shall be increased to 20% by 2020, sorry. And it also takes all the four A's of energy, that is affordability, acceptability, and um, affordability, accessibility, and it is accessible. So, where the natural gas fit in the overall refinery set. It can be used, it can be as a fuel for fire heaters and utility boilers, replacing liquid fuels. It can also be used as feed and fuel for the hydrogen generation unit, replacing naphtha if in case you are using it, and it can also be used as fuel for gas turbines. So let's look at the typical 9 MMT refinery fuel gas and demand consumptions pattern. Here we can see that 42% of the fuel consumption is required for the heaters and utility boilers, around 34% for GTG and SRG, and rest for the 21%. The HU here accounts for feed as well as the fuel for the hydrogen generation unit. In this typical refinery, I have considered for the purpose of my case study that fuel supply is greatly met in site through in situ refinery fuel gas produced and internal fuels. See, but this pie chart is specific to the 9 MMT, which I have considered it's a FCC based refinery and processing Arab crude mix. For your refinery, it may change greatly because we all know that fuel gas demand and consumption pattern changes greatly with the crude processed and the secondary processing units you have. So let's talk about the environmental benefits by switching. If your fire heaters and utility boilers are on liquid fuels like fuel oil, then how much we can save on carbon emission. So here we can see the total absorbed duty is 642 kcal per hour. If out of this 405 is already met from the refinery fuel gas, and the balance duty is 235.7. If it is met from the fuel oil, the total carbon dioxide emission will be 577. And if it is met through natural gas, there will be a net reduction. It will come down to the value of 401. So by switching from fuel oil to natural gas, there will be net saving of 176 tons per day. So you can see if the figure is extrapolated to the overall refineries of India. Mind it that these numbers may change as we talk about the different refineries. So using natural has got an added advantage as well. Then what is it? If suppose we have a fire heater which is equipped with air preheating system. So generally what operators do? We have flue gas outlet temperature which is generally capped at around 150 to 160 degrees Celsius. Why? Because we want to maintain the flue gas outlet temperature above acid dew point. So what is acid dew point? Acid dew point is the temperature below which sulfuric acid or acid gas is condensed, leading to the corrosion in the equipment downstream. So when we talk about natural gas, since it has got inherent less amount of H2S or very very almost nil amount of H2S, the acid dew point for this natural gas can be as low as 60 degrees Celsius. Thus, we have an opportunity to use this heat in air preheating system. Okay, so this will lead to improved heat recovery as well as the improved fuel efficiency. How? Because we can recover more heat in the air preheating, leading to the high temperature of the combustion air in the fired heater. So, if we talk about natural gas as feed and fuel to hydrogen generation unit, hydrogen is required in almost all the operations of refinery, whether it is hydrotreating or hydrogenation or desulfurization or hydrocracking, it is required. And as of now, the majority of hydrogen in refinery is produced through stream reforming process. We are using it through a conventional process only. So, if your HU is naphtha based, then we can say, okay, before coming to that, we can say that this is a simplified block flow diagram representing a hydrogen generation process and from where the carbon dioxide produces. The majority of carbon dioxide emission is through the shift reaction, where the carbon monoxide reacts with steam to produce carbon dioxide. And the second source of the carbon dioxide emission is in the firing, where the fuel is fired in the reformer and the flue gas goes to the atmosphere. So, if we switching from naphtha to natural gas of HGU will result in around 2.3 kilogram of carbon dioxide per kilogram of hydrogen produced. Imagine if you have around say 7,000 kilogram of hydrogen produced requirement, then by switching from natural naphtha to natural gas, you can save around 16,000 carbon dioxide. It also reduce if you're switching from, you can see that quantity of naphtha versus natural gas for the same amount of hydrogen produced will be more, and natural gas will be natural gas required is less, and delta is around 0.5 kilograms per ton of hydrogen. So what will be the more broad modification which will be required for if you change from naphtha to natural gas? Feed pumping and compression reheating section, yes. Maybe in your naphtha section, we have generally naphtha preheater, vaporizer, superheater, etc. They may not be required. Natural gas compression is required, but if the natural gas is coming from the grid, then which is generally at the higher pressure, then compression may also be not required for this modification. These are the broad modification, and the technology provider can better answer all the specific changes required for switching from naphtha to natural gas. Hydrodesulfurization may hardly be required because naphtha inherently has very less amount of H2O or nil. And secondly, since naphtha, it also, we have an added advantage as natural gas has, what do we say, has no olefins, so it will not affect my reformer catalyst. Now, coming reformer firing may change because there is burner modification may be required in reformer. Shift reaction section, yes, because when we talk about naphtha, we have and when we talk about natural gas, compared to naphtha, natural gas produces less carbon monoxide. So there will be a shift in there will be a shift reaction kinetics in HGU, and we need to check on our catalyst volume and reactor sizes, etc. Natural gas can also be used as fuel to gas turbines. Gas turbines, similarly, if we switch from naphtha to natural gas, we can save quite a good amount of fuel usage, 0.35 tons per megawatt hour to 0.25 tons per megawatt hour. And also, we shall be saving on 20 to 25% carbon dioxide emission. To conclude, natural gas holds promises, but we need to study case by case to coming on the conclusion how much when we said, and a proper thermal as well as techno-economic analysis is required for the same. Thank you.
Thank you, Megha, for the comprehensive view of how natural gas can change the emission status of refineries. I think the question of availability and the question of pricing will always be a question that will get debated in India for a while. But as far as usage is concerned, for sure, it's better for the environment. On to our last speaker for the session, Ilya Likhov. He's the CEO and founder of Neosun Energies. They've, of course, developed some very innovative business models on the solar side. And what he's going to talk about today is advancing remote energy access through hybrid power technologies. Over to you, Ilya.
Hi everyone, I'm going to be here today, and today we will talk about hybrid energy. You know, India is the top 3 economy in the world, but more important, India is the top 3 energy consumer on the world. But on the other hand, around 300 million people in India still live without access to electricity, and it's millions of enterprises cannot operate business in India, especially these enterprises who are located in off-grid and remote areas. And this is a huge problem because 300 million people, it's like a population of country like United States. And there is a solution how to provide the electricity for these enterprises and for such people. Before talking about this, let's introduce myself. My name is Yalikhov. I'm CEO and founder of Neosun Energy Company. We are a global solar energy EPC company. We build solar power station in different countries, and we already operate in Africa, in the Middle East. So totally we operate in 16 countries. And mostly we focus on commercial and industrial projects and also in hybrid projects. And today I would like to tell you about some hybrid solution we can use for Indian market as well. So it would be great if my presentation will be on the screen, but it seems it's no. Oh, sorry. Yes, sorry, it's my presentation. Yeah, it's what I'm talking about. So our company builds solar power station globally in different countries. And before to tell about solution, let's talk about solar energy market at all. So currently it's almost, so in 2022, it's achieved $500 billion US dollar. And it's growing every year around 20-25%. In 2023, it's achieved more than 600 billion US dollar. And in the last year, it's already achieved almost 800 billion US dollar. It's 2 times more than investment to oil and gas. Why? Because currently solar energy is the cheapest way how to get electricity. But more important is this way is allowed you to get electricity in any corner of the world. And this is why now the hybrid solution is also growing, because solar energy allows you to get electricity anywhere. So you no need to build nuclear power station for small village in off-grid areas. No need to build very expensive transmission line to this territory. So usually now we get electricity in such areas by diesel generator. But it's costly because we need to burn fossil fuel like gasoline or diesel oil. So hybrid solution based on solar energy allow you to get electricity in any corner. No need to bring fossil fuel to this territory. This is why hybrid solution is also booming together with solar energy market. As I mentioned before, now it's some energy crisis in this territory because it's difficult, it's very expensive to build transmission line to these areas. And the best way how to operate business there to build local solar energy and hybrid solution. And we already have such experience. We built such system in Middle East, in Africa. And how does it work? We can build hybrid system where you can have solar panels which allow you to get cheap and almost free electricity anywhere. Everywhere where we can have sun. But sun we can have everywhere, especially here in India. So there's a lot of sun here. And all this electricity we can keep and collect in battery storage. Thanks God that now this battery storage and solar panel are very cheap. Currently, solar panels and battery storage together is the cheapest way how to get and store electricity it's twice cheaper than any other energy source like coal or other fossil fuel. On the other hand, we can have diesel generator here just for making backup. So such system allow you to deploy any system with any capacities, say from 100 kilowatt to 10 megawatts in any corner of India, even in jungle or even in mountain areas. You can just deliver solar panels, battery storage, and diesel generator together, and 80% of energy you can get from solar panels, and a battery can help you to get electricity upon demand. And diesel generator we need just for backup. And even you don't have sun or your solar panel is broken, you can use this generator only for 1 hour to charge your battery and then use this electricity upon your demand. And in our company, we built a mobile containerized solution, which allow to deliver such system to any corner very quickly and deploy in 2 or 3 hours. So it's mobile containerized solution, and already everything already inside. So battery storage, solar panels already pre-assembled and is inside this container. You just bring this container to any corner, and within 2 or 3 hours, by 2 or 3 people, you can deploy the system because it's already pre-assembled. And you can use this container like a local office or small shop or country office for some hospital or maybe even for the bank. So you can operate some small enterprises or business inside this container, and then on the other hand, you can use solar panels on the roof of the top of this container for getting electricity. So you can get around 50 kilowatts from such container, and this solution is scalable. So you can scale the solution for any capacity. For example, for 1 megawatt, you just need 10 or 20 containers you connect to each other, and you can use a solution for mining facilities, for rural hospital, for rural shops, or even school, whatever you want. We built a lot of such system in Russia, in Siberia, even where we have a lot of snow. We have such system in Africa, in South Africa. So you can implement and use such solution in any corner of the world, or whatever it is. Snow territory, sunny territory, doesn't matter. You just deliver this container 2 hours and you can get electricity. There is some example of such solution. So in this example, it's around 300 kilowatts option, and this is mining company in Siberia. So Siberia is not a very sunny place, but anyway, we can provide such system for mining company who can use it for getting electricity. And we can also use it for any place, in mountain, in jungle, everywhere, in India, in Africa, everywhere. Another solution we can use is solar carports. So we can use solar panels on the top of carports, and no need to use any extra place for to put your solar panels. And this space already exists. No need to pay for any extra space, and we can get enough electricity to charge your electric vehicles. And electric vehicles market is growing very quickly now, even here in India. But I just back from United States, and I saw some very funny story, because now this market is booming, and there are a lot of Tesla on the market, but they don't have enough power to charge this Tesla. And I saw by my eyes this situation when people come to the electric spot to charge the Tesla, but no power, and they use diesel generator and burn burn fossil fuels to charge their Tesla. It looks like a joke, but it's true, because they don't have enough power. So if we can use such solution as solar carports to charge batteries and to charge your electric vehicles everywhere. So actually we can build such system also everywhere. We even don't need to connect to the grid to charge your electric vehicles. We can put this system everywhere, in the desert or in the jungle, doesn't matter. So there is some example of such system we built already. So the next step of evolution of energy system will be microgrids, and I believe that in next future we will shift from huge power generation like nuclear power generation or coal power plant to small generation. Why? Because it's much cheaper and easier to build small power system, like for example 100 kilowatt or to 1 megawatt, to get electricity in the place you really need this. So no need to transmit, no, you don't need to move this energy to 1,000 kilometers to another part of the country from the nuclear power station, because we just waste this energy for, I don't know, to warming up our universe, because we warm up our just air by using, but by warming this wire. No need to transmit this, no need to transfer this energy. We can use this energy, we can utilize this energy in a place we produce it. And I believe the future in microgrids, where we produce power stations, as we produce energy on the top of the roof of office, of any building, and just share this energy between each other within small community. It already exists in Europe. It's already growing in Africa, because if you have, for example, small village for say 10,000 people, no need to build nuclear power station to produce power for this small village. You have to build small power system for 1 megawatt and utilize it in this community. We already built a lot of such systems. For example, I just back from South Africa, and we built a 1 megawatt system for big shopping mall in small town. I even don't remember the name of this town, sorry. But this small town now powered by 1 megawatt system, and it's enough to power a big shopping mall, and at the same time to cover 70% of the demand of whole this small village. No need to deliver this energy from the huge power station very far away. So we can produce this energy and utilize this energy exactly where we live. So I believe the future in microgrids. Yeah, so there is also some examples we built in different countries. So this is what I was going to tell you now. If you have any question, I will be happy to answer. Thank you.
Thank
Okay,
you, Ilya.
thank you.
Ladies and gentlemen, with that, we come to the end of first technical session of the carbon reduction electrification stage. Thank you very much for your participation. We unfortunately haven't budgeted time for question and answers, but if there are any questions, feel free to catch any of the speakers just after the conference. We'll be happy to engage and talk about in further detail whatever is needed. Thank you so much. Look forward.